Welcome to another episode of Backroom Electronics. Now today what I have for you is a little bit different than what I normally do with my channel. It's not analog and it's not a repair. It's actually a build of a single board computer. Now this board is a modern reproduction of the KIM-1 single board computer developed by MOS Technologies to demo the 6502 processor for tiny little up and coming startup companies like Apple Computer Corporation. Now this board was designed by Bob Applegate at Corsham Technologies, and it's a beautiful board. It's beautifully laid out. I'm really excited to build this. So without further ado, let's get to it.
If you've ever built anything before, you will know that you shouldn't just slap everything on the board and hope for the best. What you actually should do is start logically, and we're going to start with a power supply and get that up and running. And I'm going to make sure that we've got voltage where we expect it to, no voltage where we don't expect it to be, and make sure that everything is exactly as it should be as we go. The board that I have received, this is one of the first revision 4 boards. This is this board. Actually, when I purchased this, the guy selling it, Bob Applegate, actually messaged me and said, "Hey, do you want the version 3 board or do you want the version 4?" And the version 4, you'll wait a few extra days, and big whoop, I hadn't ordered any of the parts yet, so I went for the version 4. And so there's the bill of materials is not completely updated, so I had to correlate the two when I made my parts purchases, which is always a little bit kind of annoying, but at the same time, I got a brand new revision 4 board, and that was totally worth it in my mind. VR1. Where is VR1? Why would I have a VR in this? I don't see a variable resistor anywhere. Okay, I might be going back to the bill of materials. Let's see. Voltage regulator, and not variable resistor. We're good. This should be off. Let's get that off of that right there so I don't risk shorting something. Now, here goes. We have power. Fantastic. Okay. Now, that means that I need to get some testing done here. 8 and 16 of IC7. That's what he's wanting me to check. Where's IC7? IC7. There's 1, 8, and 16, right? Oops, got my polarity wrong, but 5 volts, dead on. Fantastic. And then if I want to check 8 and 16 on IC10 as well, just to make sure that, hey, we've got voltage where we expect it to be. 5 volts, bang on. Fantastic. Alrighty, so let's resume. So now what we've done is we've installed the power supply, and we've tested that we had voltages where we expect them to be. And now that I've pulled the voltage away, and I've got nothing near that at the moment, so that way I don't accidentally fry something. Again, sterile environment. You always want to make sure that if you're not intentionally powering something, that you don't have anything resembling power hooked up to this board. Because, well, I've fried stuff that way before, and it's highly unpleasant. Don't recommend it. Apparently, I did not get sockets for the 556 here. That's unfortunate. Wait a minute. That's not even the right chip. His bill of materials is wrong. So, after some deliberation and some wandering around the house and some swearing and an email to the guy who designed this, Bob, letting him know about the bill of materials disparity here, I figured out what I'm going to do. Because a 556 is literally nothing more than 2 555s in one package, well, I'm going to dead bug this thing. And since I know somebody already who's not really seen dead bug debugging before, and I've not really done it a whole lot myself, I figured now is a great chance to demonstrate it and get some skill in doing it as well. So basically what I've come up with is I found this old Ethernet cable, and that's not the Ethernet cable obviously, but I've had this old Ethernet cable that one of the connectors or something went bad, so I stripped it down, and I'm just going to knock off those and untangle the pairs, untwist the pairs there, and that'll give me 8 connections for 8 pins on a 555. That'll do perfect. So let me do that, and then I'm going to have to strip those down. And I've got the pinout. I actually found on a web page a pinout for both the 555 and the 556 directly adjacent each other, so I can compare and contrast without having to do very much. Makes my life very easy. So just untwist this stuff. And like any good techie, I've got a bajillion miles of Ethernet floating around my house. So now this is unfortunately stranded Ethernet, which is not my preferred choice. I would be much happier with solid core wire, and for that reason I'd actually debated. I've got magnet wire, I've got tons of it floating around the house, but I didn't necessarily want to use this 30 gauge stuff for that because, well, 30 gauge is kind of fiddly, and on top of that you run into problems where if I knock this just right, I short something out, whereas this is going to have, this Ethernet is going to have a little bit more rigidity to it, so that way we're not going to have any sort of issues with possibly shorting out this Ethernet, this dead bug. And this has an actual insulation on it, so it's not just relying on the enamel coating of the magnet wire. And so yeah, let's get the rest of this done here. Now, because Ethernet is really fine gauge stuff, what I'm going to have to do is I'm going to have to go back to, as I demonstrated maybe in a previous video, I don't know, maybe I haven't, basically cutting the insulation with a knife. And this is not my favorite way to go about it, but given how tiny this wire is and how fiddly it can be, especially with my hands. Oops. And obviously I'm not going to need that much wire. I'm probably going to be able to cut this in half and make it work from there. I just kind of anyways. That's probably way too much wire. In fact, I can guarantee you it's way too much wire. Now, step 1 on this is going to be to tin this. I've never been any good, especially not when I throw my solder around the room. Now, looking at the pinout for the double triple here, what we're going to have is our ground down here and our power up here. And then outside of that, all of our connections for the one that I want is all along this side right here. So all my connections are going to be on this side except for my power pin over here. That's actually going to be pretty easy to do. The only downside is that I'm going to have enough to run here and then down into there without interfering with my switches or my other components in the area. Now, since I mentioned that I sent the email to Bob, he actually has already responded. He's really quick on the draw here, and he's already responded and apologized for the mix-up and updated his bill of materials for us. So if you buy one and you get your bill of materials, you won't have the same problem I did. Oh my word, my hands are just bad. I might end up having to come back to this project if this doesn't calm down. Because, yeah, I've never had such problems in my life. Now, my hand tremors can get bad, but not, that bad. Anyways, so I'm going to knock these back to about there. And the longer leads were more for my sanity, in case I did something stupid or ended up having to do this over. And even that's going to be pretty significantly long. strip our next set of wires. Now these I'm not going to worry about tinning because the tinning was more to make this a little bit easier on me. So I'm not going to bother tinning these. They'll just go into the sockets and they'll be fine. Alrighty. So now, so you can see that. That is what dead bug soldering, very ugly dead bug soldering looks like. Cool, that's hideous. Not my most proud moment, but whatever. So that way you can see that. If I'm going to be using that, I am not a smart man. Okay. Okay. Oop. Ah, missed one. This is why I double check my work. So I didn't even see that I had missed this resistor right here. Okay, now, so last night I got this built to a point where I could turn this on and you know, give it a few little at least hit the reset button and get some random garbage on the screen here on the numeric output here. Unfortunately, I don't get that. So let me actually demonstrate for you. So I get the power light just like I did before, but if I hit this reset button right here, should get display output, and I don't. Now this one, you may notice I flipped upside down. I was troubleshooting because it doesn't really mark on the board which way is which. I installed all of these and this one as well originally in a logical, what seemed the most sense to me, to have the decimal point down here at the bottom. But just in case I was wrong on that, I flipped that one right side up, just to, or other way, upside down I guess, to see whether or not that was actually going to work here. Now I have done some more poking at this. I don't believe I'm getting a clock pulse. Now, the output on a double 555 is going to be this pin right here. I guess I need to turn that back on, just in case I'm missing something there. Now, as you can see, I get nothing. Did that go? Is that going high now? So that's all the way up to 5 volts. So logic level. Okay, so it's going high. It's going about 4 volts, but it's not cycling, and this is a problem. Now, even if I change my time base, oops, that's going the wrong way. Let's go all the way down just to see what happens. You see, it jumps high and stays high. Okay, so that's going actually to 5 volts. but I'm not getting a clock in there. There's just nothing. It goes high and it stays high. So I'm going to start pulling chips, and I'm just going to just disconnect all of them, and let me actually just unplug that so I don't have any sort of unpleasant surprises here. Now I realize I'm using a screwdriver to do this, and I realize that that's not the way this should be done, but I don't know what happened to my chip puller. It's just kind of gone. I've used it once in the, I don't know how many years I've had the damn thing, but it's just gone. I really don't want to break this one. I have all of them to break. This is my one I absolutely can't. But this one took me a month to get from China because I couldn't find a good supply of them here in the US. Okay, now all the chips have been removed from the board. Let's reconnect power. And ouch, definitely just stabbed myself with one of those glue logic. Okay. Am I running? I'm not sure my. Okay. Still no clock pulse. Why am I not getting a clock pulse? Like, even if I come over here, still not getting a clock pulse. And I'm really not sure why. Alrighty, so it seems we had a little bit of a storage problem here, which with one of my cameras, and I fixed it now. And so I'm going to redo a few of the steps that I've already done, or at least walk you through some of the things that have already been done in case I don't know what was caught and what wasn't on this camera here. So effectively what I've done is, as you can see, I've pulled everything except the 6502 and this guy right here, which is a 74 LS06, which I believe is going to be driving the transistors here that drive the LED panel. So, and I'm going to verify that the oscillator is in fact running here. So let me do that. Power is off. Okay. Turn this guy on. Now, if I come over here, connect to that, and come over and look at, oops. Okay. So, as you can see right there, I have a clock pulse. Now, let's move on. I'm going to disconnect him, and I'm going to start adding more chips until the clock stops running. Now, pin 40 is the reset. That is going to be that guy right there. So let's connect in to ground, and over there. And if I hit that, nothing happens. That's interesting. Part of it is that I'm AC coupled. Let's come DC over here. Whoop. Way. We have a problem. So the CPU is not resetting when you hit the reset switch. And that is reset, right? Switch 23. Well, that is interesting. And again, as I mentioned, I did install this one upside down just to see, since the board doesn't really have that very clearly marked. But yeah, we don't, like, that goes high. Or I guess it's pulled low. Anyways, so since it's been a little while since I've done anything with this computer, it's actually been several weeks at this point. And as you can see, I've made some improvements, some usability improvements. Mostly that's what I've done, is usability improvements. I've labeled all the switches here. So I've got reset, go, stop, address, data, program counter, and plus. And then of course I've labeled all of the data input keys as well. The other thing that I've done is I replaced that stupid 556 with a proper 555 in a socket. Now the reason I socketed everything, including the glue logic, all through here, was because this is a tinker toy for me. If I kill something, I want to very quickly be able to just yank it out of the socket, slap a new one in, and move on with my life. I don't want to have to fight with anything. I don't want to have to deal with anything. Now, honestly, I could have left this 6532 off the board because all this is doing is driving the SD card system. Now, I'm not using that, and I'm intentionally not using that. And in fact, there's also a USB port here that I'm also not using. And I did that intentionally. Now, I built this computer and I bought the board and all the components and wanted to undertake this project for two big reasons. First of all, I've never really done a build of this size before. And second of all, and most importantly, I wanted to learn how the inner workings of a processor function, and with the end goal of I want to design my own processor eventually. Obviously, that's a long ways down the road, but I still want to be able to do that. Now, here is this version 3, so from here down is what's actually running right here. Now, all this does is it JSR jumped subroutine to 1F1F. That subroutine at that memory address is actually here in ROM, down here at this monitor ROM. What this is doing is it just pulls the information that's stored in address locations F9, FA, and FB and places them on the screen. So here's F9, FA, and FB. Now, what we're doing is we're loading that information from that 0-page location, incrementing it, and stuffing it back. I know people who are familiar with assembly code are going to be saying, well, you can optimize that, and sure, I can. I didn't necessarily want to write this program for the purpose of optimization. I wanted to just get a basic understanding of how the instructions correlate to an address, an instruction, which is actually just an address within the processor, how that correlates together. And I figured the best way to do that is to use some of the 3 most used instructions that I figure I will be using: load, increment, and store. Now, let's see, what else can I tell you about this machine? As you can see, that's counting significantly faster. I suspect I've got a bug here. I don't know why, but it counts faster as it gets higher up in the range, and then just flies through those last few. And I'm not sure why it's doing that. And I'm sure if I were to add a bunch of, no ops here in this first little block to slow things down, or add some other mechanism of slowing down the processor, I would end up with probably something similar happening over here, but I can't prove that. I just haven't taken the time to do that more than anything. So as you can tell, I've really only done usability optimizations, because trying to read the silk screen off the board is not fun. It's really not. Now, let's see. The other thing that I have done is I found this guy right here, which has all of the instructions and all of its variants, because the 6502 has a lot of different variations on their various instructions. You have immediate, absolute, 0-page, which is a performance optimization. It takes 1 instruction cycle less to pull, because you're not pulling a 2-byte instruction, or a 3-byte instruction, I guess. You're only pulling a 2-byte instruction, 1 for the instruction and 1 for the location and RAM. That makes the 6502 actually run a lot faster, because this processor only operates at 1 megahertz. I mean, that's how fast the 6502 in the Apple II ran. That's the Commodore 64. That's a lot of machines, was 1 megahertz 6502. So any performance optimization you can get by doing 0-page and the like, that's going to be pretty useful. Now, this is basically the same thing as over here, but I'm sure you've noticed this is almost impossible to read. It's probably absolutely impossible to read on the camera, but in person it's just extremely hard. I can read it, but only just. What I really want to do is redesign this and kind of make it a little bit clearer, because even in its current state, it's kind of hard to read. Like, you can read that, but it's kind of hard. I mean, this is basically a scan of a photocopy of the original instruction reference card that's been blown up to a full page. I suspected this was actually smaller back then. So the other thing is that I've got this, and this gives me the hex to instruction conversion. So you've got your least significant digit over here and your most significant digit over here. So you've got the dash over here. That is your first character here, your first number on the left, and then your second number on the right is going to be over here. So if we're looking at a load accumulator, and let's do 0 page, that's, I believe, A5, but let's confirm that. So A, go over to 5, indeed it is. Load A, 0 page, A5. Now, let's see. What else can I tell you about this machine? That's a good thing. So, using the computer. So you've got your reset button. You actually don't have to press this. I said that in a previous video when I was troubleshooting that you had to press the reset button. That was true of the original KIM, and it was true up until the version 4 board, the revision 4 board that I have here. He added this little microprocessor. This is just a director chip. And all this does is when you turn the computer on, it cycles the reset pin of the 6502, low and then high. So that just resets the processor, is all that does. So I don't have to press that and then start entering my data. The other thing is that there's a set of subroutines that most KIM-1 owners that use the KIM-1, actually use the KIM-1, are going to use. And there's a number of different things that you just enter in and you just get used to if you have an original KIM-1. Obviously, this is not an original KIM-1. Those subroutines are already set in the ROM here. So I don't have to worry about any of that. It just already works. Comes out of the box already working, so I don't have to mess with it. Now, to navigate this computer, you have go and stop. Obviously, go runs the program, stop stops the program. The other thing that go will do is if I throw this switch right here, this is marked SST or single step. So if I hit go, all I'm doing is incrementing by 1 instruction. And you can actually watch what the processor is doing as it runs through. Or we can switch it back out of single step and just, it'll do its thing. Now, to actually navigate all of this, you have your address button right there. And then by convention, your addresses, your programs are going to start in address location 0200. And it's not strictly necessary on this computer. I do it just to follow that convention because if I get a hold of an original KIM-1 and want to use it, I don't want to build bad habits. That's all that is. So to scroll through your instructions, you can just hit the plus button and you can see there's all of my instructions for this whole computer. And then to change something, so if I want to go to, let's change something completely unrelated to this computer, this program here, I can change it by pressing the data button, and then, whoops, wait a minute. Apparently that's not a RAM location I can change. So let's do, if you haven't noticed, I don't know the memory map of this computer very well yet. I'm still very much learning this computer. I've only had it for a month, maybe a little bit more than that, but I haven't really used it much. So let's go to, and try changing, yeah, so that'll let me change things. So I can press the address button, and then I can set whatever I want. And then if I want to go back to where I was, I just press the program counter, and it takes me right back. And then, oops. So if I, go, then actually let's single step that back over to somewhere like there where I can easily come back to that. Now, 0206, that's in the program counter. So if I hit address in 0100, there's my FA that I stored a little bit ago. Now, I don't actually have to hit a store button when I, oops, when I change that location in RAM, that just is automatically written to RAM. So the minute I press a button, it just automatically writes that to RAM. That just generates a write. So then if I press the program counter, right back to 0206. So that makes things very, very easy. I can jump around anywhere I want, in anywhere in the memory space, and see what the program is doing. And then all I have to do to come back, I don't have to remember where I was. I just press the program counter button. Very, very handy feature. Now, what else to say about this computer? Oh yeah, this computer has an EEPROM, an additional expanded ROM that Corsham Tech, or I don't know where he got this from. It could have been something he wrote. It could have been a conglomeration of a number of different pieces that he just compiled together and put together for this computer. I don't know where necessarily he got this. But I do know that this has extra games on it, and it has other things that just come built into the computer. They do require using the USB port, so I not use that at all. I don't know what it, I don't actually know what's on this ROM. I've never used it. I do know that if you change over to this ROM right here using this switch, it disables this entirely. So given that I can't enter from here, that's the only way left to access the system. So I can't use that. But that's okay. That's not why I bought the computer. The other thing that I did was I printed out this fat novel right here. This is the instruction manual, the programming manual for the 6502. Not for the KIM-1, just for the processor. So this includes a lot of really good information about how the processor handles RAM locations and the accumulator and load instructions and how you can work with arithmetic. So there's decimal addition, so the set decimal mode, and then load accumulator, add with carry, and then store accumulator back into a RAM location. So it walks you through a lot of very useful information. But obviously I haven't had a chance to read this. I just got this printed 4 days ago. Yeah, about 4 days ago. So I've not had a chance to read this too closely. I have, however, used this to write a few programs on my Apple II. I just used a PDF version on my Chromebook while I had it, sitting next to me on my Apple II. That's really all I've used this manual for at this point. So yeah, this computer's been really neat. I unfortunately have not had a chance to really play with it as much as I would have liked. It is still a very beautifully laid out board. I'm still very happy with this computer. And I know that it may have sounded like I was angry at Bob or irritated or, something of the sort. My reference to wandering around the house swearing, that was not swearing at Bob. That was swearing at the fact that I was afraid I wasn't going to be able to build this computer that night. I had been looking forward to building this machine for days and days and days and weeks. It took me over a month to get these 2 chips alone. And without this one, I don't have driver video output here or display output on the numerical output. So I can't even use the computer without at least one of these 6532s. So that's what the swearing was about. It was nothing directed at Bob. Bob was absolutely on top of things. Anytime I emailed him, he responded within minutes, usually, at most a few hours. He usually responded, usually if I was actively working on the computer, he happened to be around his machine and would respond pretty quickly. So when I mentioned the 556 versus the 555 and not being able to, and then again later not being able to use the reset switch, he responded to both of those emails within minutes. Like, he was extremely quick on the draw. He's great to work with. He, as I mentioned, he offered me the revision 3 board that was complete and ready to go, or if I was willing to wait a few extra days, he could get me the revision 4 board. I told you that I opted for the untested, nobody's bought it before revision 4 board instead of the 3. And again, that was literally my entire problem, was that I had an untested board that nobody had purchased before. So he didn't have any guinea pigs, so I was effectively that guinea pig. And I'm okay with that. I was expecting that when I bought this board. It's been fun, it's been frustrating, and it's been exactly the learning experience that I have wanted from a computer like this.
Well, I hope you enjoyed watching me build and figure out what was going wrong with this computer. If you liked what you saw, make sure to give me a thumbs up, and if you want to see more content like this, make sure to subscribe. Catch you next time.